Hi, we are Group 1, Section D. Our topic for the presentation is Sustainable Practices in Power Sector.
The objective of this study is to identify the best practices and the benchmark standards which set apart the organizations oriented towards sustainability from the rest and thus set a proven methods and ways of getting a step closer towards sustainability. Power is one of the most critical components of infrastructure crucial for economic growth and welfare of nations. The existence and development of adequate infrastructure is essential for sustained growth of the Indian economy. India's power sector is one of the most diversified in the world. Sources of power generation range from conventional sources such as coal, lignite, natural gas, oil, hydro, and nuclear power to viable non-conventional sources such as wind, solar, agricultural, and domestic waste. Electricity demand in the country has increased rapidly and is expected to rise further in the years to come. In order to meet the increasing demand for electricity in the country, massive addition to the installed generating capacity is required. Indian power sector is undergoing a significant change that has redefined the industry outlook. Sustained economic growth continues to drive electricity demand in India. India's wind energy market is expected to attract investments totaling rupees 1 lakh crore by 2020 and similarly the wind power capacity is estimated to almost double by 2020. Hence, in this context, it has become quintessential for organizations to not only gauge and track the best practices and benchmarks, but also to follow and adopt some of those practices for a sustainable world.
Hi, I'm Ayushi and I'll be saying about the investment scenario in the energy and power sector. Around 293 global and domestic companies have committed to generate 266 gigawatt of solar, wind, mini hydel and biomass-based power in India over the next 5 to 10 years. The initiative would entail an investment of about $310 to $350 billion. Between 2000 and March 2016, the industry attracted $10.48 billion in foreign direct investment. Some major investments and developments in the Indian power sector are as follows. The State Bank of India has signed an agreement with the World Bank for Rs 4,200 crore credit facility aimed at financing grid-connected rooftop solar photovoltaic projects in India. The World Bank Group has committed to provide $1 billion for India's solar energy projects and plans to work with other multilateral development banks and financial institutions to develop financing instruments to support future solar energy development in the country. The Ministry of New and Renewable Energy has signed an agreement with German-based KfW Development Bank to fund Rs 300 crore floating solar projects in Maharashtra and Kerala, which is expected to generate over 310 gigawatts of green energy. CLP India, one of the largest foreign investors in India's power sector, has acquired a 49% stake in SE Solar, a special purpose vehicle set up by Suzlon Group for building a 100 megawatt solar energy plant at Veltur in Telangana for Rs 73.5 crore. The Ministry of New and Renewable Energy plans to launch an integrated bioenergy mass with an investment of Rs 10,000 crore from fiscal year 2017-18 to fiscal year 2021-22, aimed at enhancing the use of biofuels like ethanol and biogas and reducing consumption of fossil fuels. The world's largest single rooftop solar power plant of 11.5 megawatts capacity spread across 42 acres was inaugurated in Bees Dera campus in Amritsar, which is expected to generate power for approximately 8,000 homes. Canada's second largest pension fund, Kasi de Depot Eat Placement du Quebec, has set up its office in India and committed to invest $150 million in the Indian renewable energy sector over the next 3 to 4 years. Suzlon Energy, one of the India's leading wind turbine maker, plans to set up 3,000 megawatt power generation units of solar, wind and hybrid sources in Telangana with an investment of Rs 1,200 crore.
Hi, I am Ashish. I will be explaining different dimensions of sustainable development. Different dimensions are environmental, social and economic. Under environmental dimension, we are having different effects like emissions, biodiversity and resource depletion. The different mechanisms which are causing emissions are discharge from power generation plants, decrease in low-level emission as a result of electrification. The different biodiversity effects are impact on natural ecosystem, enhancing biodiversity by conservation measures. Different resource depletion are being caused by non-renewable resources and precluding their availability for future generation. In social dimension, we have social welfare, poverty impacts, relocation, and others. So in social welfare, we are having mechanism of employment and supply of electricity. Poverty impacts include access to electricity. Relocation includes construction of dams, and in other social dimension we are having role as a corporate citizen. In economic dimension of sustainable development, we are having value creation, value distribution, multiplier effects, and economic growth. In value creation, we are having provision of goods and services. In value distribution, we are having employment, taxation, and dividends. In multiplier effects, we are having procurement of goods and services. And in economic growth, we are having technological competence and innovation.
Hi, I'm Arpita. I'll be speaking about sustainability practices followed in power sector. Switch over to variable frequency drive from constant speed drive in large pumps across the power plant. Some of the advantages are great control in switching on and off, speed control, increased power factor, switch over the energy efficient light like LED and standardizing the AC temperatures to 24 degrees Celsius. Now the comparison has been done between LED, LCD and incandescent. The first on the basis of first comparison, it is the lifespan of the light bulb, which in LED is 50,000 hours, in CFL is 10,000 hours, and in incandescent is 1200 hours. The cost per bulb in LED is $35.95, in CFL is $3.95, and in incandescent is $1.25. The total savings we get in LED is $85.75, in CFL is $89.75, and in incandescent is $352.50. Companies have undertaken LED projects in combination of electricity generation through rooftop solar panels. Some of the companies who have undertaken these projects are NTPC, Tata Power, GMR. Rainwater harvesting in various locations to tap the rainwater and utilize for service purposes used by Tata Power to clean its 107,000 solar panels to maintain the efficiency. It also reduces the cost by avoiding purchase of desalinated water. Next is fly ash utilization. The fly ash generated at NTPC stations is ideal for use in manufacture of cement, concrete products, cellular concrete products, bricks, blocks, tiles, etc. Fly ash utilization is an important operational metrics in many power plants. Companies who have effectively implemented fly ash utilization technology are NTPC, Tata Power, GMR, General Power. This technology helps the thermal power plants in following ways. Fly ash needs ash dikes for storing. A 1000 megawatt project requires around 1000 acres for ash dikes for a 25-year period. Using fly ash utilization technologies, power companies can reduce the land required for setting up new power plants. 1 ton of cement requires 0.2 tons of fly ash. Fly ash could be used to generate revenue for thermal power plants as well as reduce the cost required for production cost of the cement. The next topic is CINPEEP. Center for Power Efficiency and Environmental Protection was established to take initiatives to address climate change issues as well as improving the overall performance of coal-fired power plants. It was set up in collaboration with USAID and NTPC. The center functions as a resource center for acquisition, demonstration, and dissemination of the state-of-the-art technologies and practices for the performance improvement of coal-fired power plants for the entire power sector of India. The cost saving by NTPC based on CINPEEP recommendations were cost savings of approx 11 million tons per annum, cost savings worth rupees 16,100 million, 3% carbon dioxide reduction per annum. The above facts are based on 1% improvement in efficiency.
Hi, I'm Anurag Patnaik. Now, taking the discussion forward, there are some other technologies which are more advanced than the technologies that have been discussed by my friend Arpita. These are quite non conventional in nature, per se, their industrial use. So, taking the discussion forward, first technology is carbon capture and storage. In this technology, we can capture 90% of the carbon dioxide emission produced from use of fossil fuels in electricity generation and industrial process. Furthermore, the use of CCS or carbon capture storage with renewable biomass is one of the few carbon abatement technologies that can be used in a carbon negative mode. Actually, it is taking carbon dioxide out of atmosphere. Now there are three stages to CCS: capture, transport and safe underground storage. In capture, first the carbon dioxide is removed or separated from coal and gas, power plants, and from the manufacturing of steel and cement. Now there are three types of capture: post combustion, pre combustion, and fuel combustion. Through this process, we can capture 90% of the carbon dioxide emissions. Now the second step is transport. The carbon dioxide is compressed and transported to a suitable storage site. It is usually carried out in a pipeline. Ship transport is also an option for offshore carbon dioxide transport. The last step in this process is storage. The carbon dioxide is injected into a suitable storage site deep below the ground. Storage can either take place in depleted oil and gas fields or deep saline formations. Now, some of the major companies using these technologies are Chevron and Shell, the major oil producing companies in the world, NRG Energy, a Canada based energy. Now, there are some companies that provide these types of solutions, CCS solutions to the companies, and the prominent companies on our list are CO2 Solutions, Climeworks, Carbon Engineering. Now, coming to our second prominent sustainable practice in technology practice, sustainable practice in the industry is cogeneration. Cogeneration or combined heat and power is the simultaneous generation of useful thermal energy and mechanical or electrical energy from a single fuel source. Because CHP or cogeneration recovers heat that would otherwise be wasted, for example, from industrial process, it makes much more efficient use of primary energy. In simple words, we are not going to waste the heat that is produced from our industrial processes, but we are going to use that heat to produce electricity or mechanical energy for further processes. Now, this technology is efficient when it is worked in a distributed power distribution centers, not a centralized power generation company. So it is currently not being used by big players, but it is currently used by small players like Cogen Power Technologies and Trigen Power. South Korean government has also given a mandate to facilitate supplying 12.5% of Korean total power generation through distributed generation or cogeneration by 2029. Now, some of the other prominent sustainability practices in power sectors are fuel switching strategies. In these strategies, companies are using multiple fuels to reduce their emission of sulfur dioxide and nitrogen oxides. These are used in conjunction with low pollution technologies such as flue gas recirculation, two-stage combustion, and low NOx burners that reduce NOx emission by restricting the working temperatures in boilers and gas turbines. Now, this strategy is currently being followed by companies such as TEPCO, Kansai. In India, GMR is following this technology in its currently constructed power plants. Second technology is EcoPower Energy Solutions. EPCOR, a company in Canada, launched a green power program in 1999 to support more environment-friendly power options. EPCOR residential customers can choose to purchase blocks of green energy generation called EcoPacks. Now they have to pay a premium above their monthly power bill, but the catch here is they would get completely renewable energy generated from renewable sources. Now, as per an estimate, IPCOR customer who supported the green power program contributed to reducing carbon dioxide emission by 2 tons, sulfur dioxide by 6 tons, and nitrogen oxides by 4 tons, and particulates by 1 ton. Energy buyback from customers. It is the third practice used in the industry. Exelon, a subsidiary of Comet, is offering to buy back renewable energy from its customers. Now, the EcoPower, this company is able to fully meet the renewable energy requirement of Chicago and Illinois through this practice, and it is the largest municipal energy deal in US. Okay, so concluding our presentation with this, thank you.